Hello guys, welcome back to my programming series. My name is Mike Matthew KE, and today we're going to be learning about operators in programming. As usual, I'll be doing it with both Python and C++ so that we can have a bit of a comparison between the two languages. For operators, there's not much of a difference, but we'll delve right into it so that you can see how we use these operators and what operators are. So in terms of definition, basically operators help us to perform some operations on values and variables. We'll dive right into it so that that explanation makes more sense. So I'll just switch to my screen here, and as you can see, I've made a bit of notes on operators. So these are examples of operators. So arithmetic operators, I think these are the most obvious ones. We have addition, subtraction, this will be multiplication, this will be division, and this will be modulus. Then we have comparison operators, which you can see there, and logical operators. So we'll just start with the arithmetic operators, putting it into practice, and we'll just do it simply. So to show how they work, we'll just be doing a print for each of them. So for addition operator, I think these are the most obvious ones. So if we add and then we run, we get our value 6 here. 2 plus 4 is 6. If you are doing subtraction, let me save that, then you run, we have -2. If you're doing multiplication, just change the operator here, we have 8. And then if we're doing division, this should bring us half, which is 0.5, as you can see. And then we have modulus. So I believe the first 4 that we've gone through are more self-explanatory. Perhaps modulus might be a bit new to some of you guys. So modulus is basically whenever you're doing a division, there's usually a quotient and a remainder. Okay, so so for example, if you're doing let's say 2 divided by 1, right? So you'd have 2 as your quotient and 0 as your remainder. Just put that in. Right? So something like this. So the modulus, if I run this, this is the same as 1/2. So you can see the modulus of this is 2. So what that means is the modulus is the remainder that we get, right? So if I write it down here, so 2 divided by 4, we would get 0 with a remainder of 2. So you can see when we do 2 modulus 4, what we get is this remainder value. And that can sometimes come in handy whenever you're doing operations, depending on what your program is doing and what your logic is. This might come in handy. Okay, so that's basically what modulus is. So next, we can look at comparison operators. So comparison operators are exactly what comparison means. You're comparing between two different values. Okay, so for example, if you have the easiest one I can do is if you're comparing if true is the same as false. Okay, true equals false. So this is the comparison operator, equals. So remember when we have just a single equals here, it's an assignment operator. Okay, when you have a single equals, it's an assignment operator, which means we're using it to assign a value to something. Okay, so when you do true equals false, of course we expect the answer to be false, and that's the answer that we get here. We can also compare between variables and values. So for example, if you have a equals 2 here, and we're comparing it between across these variable types, we get the value false. So for Python, it's possible to compare between different data types as well. Okay, though the best will be, for example, we use, let's use integers in this case. So if a equals 1, of course we expect to get the value false. If we put a equals 2, then we expect to get the value true, because a is actually equal to true. That's the value of this variable. So that's one of the ways that you can use this this operator. We also have this, which is greater than, a bit more obvious in arithmetic. So, for example, if we put a is greater than 2, of course we expect this to be false, because a is equals to 2, but it's not greater than 2. If we change this to maybe 1, then we'll expect this to be true, because 2 is greater than 1. Same for less than here. This is the less than operator. If we run it, we see 2 is less than 2 less than 1 is false. So that's what it produces for us. And then maybe I can put a bigger number so you can see how it works as well. So 2 is less than 3 is true. So there are these other operators here. The two where you can do greater than or equal to. So for example, if I put 2 here, so this means greater than or equal to. So is 2 greater than or equal to 2? So any number that is either this value or greater than that value will be true. So you can see here, a is equals to 2 is true. If we put 3, we expect it to be true. And the second, the number gets smaller than 2. Let me put 1. You can see a greater or equal to 1. Oh, that's my bad. It's if we put 3, we expect it to be false, right? And then if we put 1, then we expect it to be true, because this is greater than or equal to. Same for less than or equal to. Same logic. Less than or equal to, we have false, and then for 1, if we have 3, then it will be true. And if we have 2, then it will be true because it's equal to 2. Okay? And then we have this last operator, which is the opposite of this equals to. This is not equals to, okay? Which will be something like this. So a not equal to 2, that's false, because a is equal to 2. So that in actual sense, a is equals to 2, which means a not equal to 2 will be false. If we change this to any value other than 2, then it will be true, because it is true that a is not equal to 1. Okay, so those are comparison operators. Most of this will be a bit more obvious. It's just syntax that we're looking at mostly. And then now we have something called logical operators, something very powerful that you'll be using in your code. So what logical operators are is you do a logic between two values. So the best way that I can define it is, if we have, for example, AND, where by definition, if you have true and true is equals to true. However, anything other than that, you'll have, if you have true and false, this will be false. If you have false and true, this will also be false. And if you have false and false, this will be false. So this is just logic for those who have done computer science. There's this section that you usually do about logic, and this is the result that you get when you're doing AND. So we can try to approach that in practice. So we can do, for example, print. So for this one, we'll do more directly true and true. True and true, we expect to get the value true. If you do true and false, we get the value false. If we do false and false, we expect to get the value false. That's just the logic. Basically, and means this value is true and this value is true. So both conditions have to be true for the result to be true. And this might seem a bit redundant the way it looks like, but you can see we can combine it with these operators. So for example, if you're doing a comparison, maybe you can do a comparison between, let's say, if you have a variable a equals 2, so we can do a is equals to 2 and a is greater than 1. Okay, so this by default, as you have seen before, it results to the value. Sorry, this is supposed to be equals, not an assignment. So this by default will equals to true, because a, the value of a is actually 2. So this will be true. And then a is greater than 1, that is also true. So if we run this, we'll get that this whole operation that we're doing here results to the value true. Okay. So there's another operator which we have, that is the brackets, that usually encloses a specific operation. Okay. So for example, here we can do, it's something that I've not mentioned or placed up there, but we can use the brackets the same way that we do it in mathematics. We can enclose it in brackets, so that we can, by definition, know that we are evaluating this on its own and this on its own before we do any other operations outside these brackets. Okay, so that's another way that can help, especially when as you're coding, it can help you to be able to visualize how you're doing it. And in some cases, also the program also considers when you put these brackets, because it will also evaluate whatever is in the brackets first before it operates everything else. Okay, so if you run this, it will still be true. Okay, so that's one of the ways that you can use it. Then we can go to OR. So just on my case, I can change this for you. So for you, maybe if you're noting down, you can just note down an extra line later. So for OR basically means at least one value is true. Okay, so if it is OR, in this case, true and true, this will be true or true. So true or true will give us true, true or false will give us true, false or true will give us true, false or false will give us false. Basically, it means one value, at least one value is true. That's the evaluation that we'll do here. So I'll come here and do OR. For this one, I'll just do it directly so that we can see the results. So true or true. Okay, so here when we do true or true, we get true. If we do true or false, we get true. If we do false or true, again, we get true. And then when we do false or false, we get false. Okay. So again, you can still use it the same way that we use AND, where we were defining a bit, where we were doing, let's say, A equals 2, and or let's say A is greater than 2, for example. So for this one, since A equals 2 is true, then it will evaluate. So you can also realize that this is the same as A greater or equal to 2. So if you are to expand this, this would be the expression that you would have by default. Okay, so this operator also reduces the amount of logic that you'll have to put in place in order to evaluate the logic that you are trying to do. Okay, and then at the end of it, we also have NOT. So NOT is basically just the same way you'd say it in English, not not a certain value. So for example, it will just give the opposite of what you have. So if you say not true, then you'll get false. And if you evaluate not false, you'll get true. So it's the opposite of the Boolean value that you're getting from this. So so far you can see that logical operators deal with Boolean values. It deals with when you're comparing things using Boolean values. So whatever operator you use, for example, if you're using a comparison operator, so for example here, if you're doing not A equals 2, so already we know A is equal to 2, so this will be true. But then our operation is not this, not true. So we expect our value to be false. So if I run this, you'll get the value false. Okay, so that's generally how it works. I hope for the newbies out there it makes sense. It will come a lot easier when you're doing it more and more in practice, but that's just how the logical operators work and all the operators in general. So we'll do a contrast of this with C++, where actually it's not much of a difference. So you can see the arithmetic operators are almost the same. Actually, they're exactly the same. We have comparison operators are exactly the same again. And then the logical operators now have something that looks kind of funny. So for the sake of this, we're just going to do a quick run through of, sorry, this is supposed to be %d. So we just do a quick run through of maybe 2 plus 3 plus 4. Remember our semicolon, and then we run it. All right, so that we have our value. So remember %d. Remember %d. We get our value 6 here. So remember %d is our formatter for integers. Okay. So for example, if you're doing this will be the same for subtraction, for multiplication. However, we have this scenario where we have 2 divided by 4. So what should happen in this case? So you see we are doing %d, which, like I said before, is supposed to be for integers. So if you try to run this, we'll get the value 0. And someone might be asking, but why are we getting the value 0? The thing is, this %d is supposed to be for integers, not for float values, because this operation will result in a float value. Okay. So if you want a float value, we must do %f. Okay. For this one, there's a bit of a. It's usually better if we do it we specify that these are actually floats. That's something that comes with C++. Usually you'd find that it's better if you define. So this is something, a new way that you can define your floats, so that the program can be able to pick up that it is a float. Because in this case, we're just giving a value, but we have not assigned it, we have not said that it is a float. You see, if we are assigning it as a variable, we'll say float a equals 2.2. Let me just call it 2, for example. So in this case, we already know that this is a float value, and even though we are assigning it this way, it will be able to interpret. You can even see by default, the interpreter believes that this is an integer in the first place. So the best way to declare your floating point values in C++ is to add this F notation after your declaration of the number. Okay, and if you're using this F, you must also have your point 0. Okay, so that's something new that you can that you need to know about declaring the defining the floating point values. Okay, so if I run this now, we should be able to get the result 0.5, not like before where the program was unable to know whether this is supposed to be interpreted as an integer or as a float, okay? So that's what happens whenever you want to deal with a floating point, you do %f. And if we do %b right now, which is supposed to be an integer, you see what will happen is you get 0. You'd ask why? That's because our result here, we are expecting 0.5. So if we are dealing with an integer, what the program will do is it will truncate so that we have only whole numbers. So we'll remain with the value 0. That's one of the things that you have to be careful with whenever you're doing the programming, especially in C++, because it's very precise. You need to be very precise about how you're declaring and defining your variables. Okay. So if I change this to A and %f, at least that helps us as well. We get our floating point value. So you can as well use the floats on your definitions. Okay. And then we also have modulus. So modulus works the same way. And typically, modulus will be done on integers, not on floating point values. So you can even see our IntelliSense is complaining about this. So typically, you would do something like this. Oh, there's a bracket missing there. So modulus of 4, which we expect the value to be 2. Right. This is what we're missing. We're missing because we're expecting to get back an integer. We should put it as integer. Okay. So you can see our value ends up being the value 2 here, right? The same way that we had it in Python. So this is how it works by default. And then for C++, as you can see, you have to be very precise about how you're declaring and defining your variables. Because here, even in the printf, you need to know whether you're going to get an integer or you're going to get a floating point before you print it out to the console. Okay. The other thing that you can do is, so for example, if you have a boolean which we say is true, and then we print a boolean. So you will ask, what will we use here to print out a boolean? So for booleans, what happens in C++ is the true value is the integer 1, and the false value is the integer 0. That's how C++ operates. So here, this would print it as an integer. But even though we have a boolean here, we'll print it as an integer. But we would expect that the value it will print is, if it is true, we expect the value 1, and if it is false, we expect the value 0. So if I run this, so given our value was true, we get the value 1. And then, if we do false here, we get the value 0, as you can see. Okay, so that's how it basically works for C++. And also, just to show a bit of contrast, you can see in C++, false is written with a small f. However, in Python, we write it with a capital F. This is Python syntax. That's also one of the things that you have to note when you're dealing with this. Okay. So, given we know how our Boolean values will print out, then we can now look at the comparison operators. For example, we can do 2 == 2 and print that. So we expect the value 1 because it is true. So for these ones, if we're doing not equals to, we expect the value false. So there we go. If it is greater than, less than, the operations will be the same up to the end. Okay. For all the comparison operators, there's not much difference happening. Now, when it comes to logical operators, we have something that looks very funny here. So, allow me to translate this from Python to C++. So we have AND is now this, the 2 ampersands. We have OR as the two pipes, and then we have not. Just put it as a comment. Not is this exclamation mark. So how they are used? So I'll start with not, which is more direct. So not is placed before the variable that you're declaring by default. Okay. So it's the same way actually in Python. If I just double back to Python, you can see that not, you put it just before whatever value you're evaluating. Okay. So here we'll do the same. So since our value of a is false, the boolean is false, then not a should result in the value true. And when you print it out, you expect the value 1. So if I run this, we get our value 1, which is true. So that's how not works. And then we have and. So and will work the same way. If I do true, true, and true. Okay. Of course, remember, true and true, we expect the value to be true, which is 1. If we have anything other than, if both values are not true, then we result in the value 0. Same for or. If we have or, given here, this evaluations will be the exact same way as Python. I'm just moving a bit faster. So true or false will be true. False or false is what will result in. False or false will result in false. Okay. And still we can also combine this. So if, for example, I change the value integer to the value a to an integer with a value 2. So here we can assign, again, remember we're using these brackets to define that this is the operation we want to execute as a block before we do any other operations inside within this line. So we can do a is greater than 2, or a is equals to 2. There's a bracket missing here. So one thing that you should note, you see every bracket has a closing bracket, and then that's what I would define as scope for that specific bracket. So you can see for this bracket we are enclosing it to this one, so we're evaluating this block on its own. For this bracket we have this one, so evaluating this bracket on its own. And then for this bracket of the printf, we have this one. So for this one, it's for a function, of course, where we have two parameters separated by this comma here that we have right here. Right? So this again will be the parameter defining scope for the function. Okay, so where you place your brackets is very important, and whenever you place a closing bracket, it will close the most recent opening bracket. Okay, so this bracket will close this bracket. It will always take the closest item. Okay, that's how the program will evaluate it. So back to this operation that we're doing it, where we're doing a is greater than 2, or a is greater than, or a is equals to 2. So of course our value will be true, which is a value 1. Okay. So that is what operators are in programming. That is what we do when we define operators. Later we'll come to see how we can use them more in-depthly, as for now we're just doing the basics. There are actually more operators. These are not the only operators that exist. There are more operators, but those will come to be seeing them later in our practice when we're doing a bit more advanced programming. So join me next time where we'll be doing something called conditions in programming. And I hope you have enjoyed this lesson. I hope you're getting your programming skills along. I hope you're getting excited for what you're learning. And I hope to see you next time. Please click on the subscribe button, like the video so I can get feedback, I can get the the morale to keep going, so that I know that I'm also helping you guys out. If you have any questions or anything that you'd like for me to look at in programming, please just leave a comment. I'll look at it, and then we can maybe do something. It can involve something that you can teach in the future. I hope to see you then.